Hello. The next lab that we're going to do is on high energy physics. So if you would go to Canvas, Modules, Labs, Unit 4 Labs, and then down at the bottom you're going to click on lab number 19, which is on high energy physics. So I got this lab from the United States Energy Department, and it's pretty good. Some parts of it you may be able to do, some parts you may not be able to do, other parts of it you will not be doing. So you want to pay very close attention. But before you look at this material, make sure and go to modules and lectures, and then watch the lecture on fundamental particles and fundamental forces. So watch that series of videos first before you try to do this lab. So once you get into the lab, you're going to go down to the concept introduction, and there is some reading that you're going to need to do. So there's 2 pages worth of reading, and read all of that information. Should be able to understand it, especially after you have done the lessons on fundamental particles and fundamental forces. And then I'd also like for you to take a look at the chart that follows it that says Standard Model of Fundamental Particles and Interactions. So you should, at this point, understand what's inside the atom, what's inside the nucleus, what's inside the protons and neutrons. So you should understand that. And then you should also understand the concept of the quark. You should also understand the 4 fundamental forces and the carrier particle for each of those forces. So that's the main thing that I want you to get off of that chart there. You can read the rest of it if you want, but it's not like you're going to be tested on that part of the chart. Then underneath that chart is another picture that shows what a super collider looks like. And a super collider collides fundamental particles like protons, and then what comes flying out of it are the more subatomic particles that they're trying to investigate. Okay, after you have read all of that material, then you're going to go up to the pre-lab part, and you'll notice that there is activity number 1, which is basically true and false questions. So there's 15 of them. So I want you to do all 15 of those questions. So off to the side, you're going to say number 1, answer yes or no, or true or false. Question number 2, true or false. So that's how you're going to record your answers for activity number 1. Okay, now go down into the actual part of the lab, and we're going to go down to the procedure part. And go to activity number 2, which you should be able to do. So activity number 2 is kind of like one of those brain teaser things that they give you in elementary school to see what your IQ is. So if you look at the picture given there on the left, you'll notice it makes a particular kind of shape. That shape is created by using only 2 kinds of geometric figures. Now, I'm not going to tell you what they are, but you take those 2 kinds of geometric figures, and depending on how you hook them together, you can make any of those figures in on that left hand side. So on the left hand side, those same 2 geometric figures will not be able to make the picture that is on the right hand side. So only really just concentrate on the other side, on the left hand picture there, and see if you can figure out what two geometric figures, when you put them together, you can make that thing. Then you're also going to write down what are the rules for connecting those two geometric figures. So, what's the point? What has this got to do with fundamental forces and fundamental particles? Well, protons, for example, are a pretty complicated object, but yet they're made of simpler particles, quarks. So similarly, this kind of complicated looking picture is really composed of very simpler, smaller objects. And then the idea of what are the rules for hooking those things together is very similar to what are the forces that hold our universe together. So these are two things that high energy physics people are always trying to figure out: is what are the most fundamental particles in the universe, and then what are the rules for holding those particles together. So you should be able to do that activity. Okay, now we're going to go down to the next activity, activity number 3. And now for this one, you still should be able to do it at home. Now for this, what you're going to need is like a game board from like a Monopoly game, or you could even use a piece of cardboard for this. You're also going to need some kind of a geometric shape, like a square, or a circle, or a triangle. So you should be able to find these kinds of objects around your house. You'll also need a ball or a marble. And now what you'll do is take the geometric figure, so the triangle or the square or whatever it is, put it underneath the board so that you can't see it, and then you're going to take a ball and you're going to roll it underneath the board and observe how the path of the ball is deflected once it bounces off that object. So that, let's say that there was a square underneath the piece of cardboard or underneath the game board, and the marble or the ball runs into it and it ricochets off at a particular angle. Well, if there was a triangle underneath there, then it's going to ricochet off at a different angle. So now this is best done with two people, so that if have one person put the geometric figure underneath the game board, and the other person doesn't see it, okay? And then it's the other person's job to roll marbles and things underneath the board to try to figure out what was the shape of that object. So try this with your kids or significant other, and see if you can do this. So that's going to be activity number 3. Okay, let's go on down to the next activity, activity number 4. Now this is one that you probably may not be able to do. You're going to need a magnet for this. Preferably 2 magnets would be the ideal for this. It calls for magnetic marbles, which are little balls that have a magnet inside of them. And I realize that you probably don't have magnetic marbles, but you probably do have some magnets around your house. So here's what I want you to do, is to place a magnet underneath the game board. Okay? Now it needs to be pretty close to the surface of the game board. Okay, and then take your other magnet and then run it over the top of the game board and see if you can figure out where that other magnet is located at. Now another thing that you could try is compasses. So if you've got a compass that you use for hiking or for camping with, you could also detect the presence of that magnet by using a compass needle. So you might want to try that one. Another possibility is if you have iron filings. So iron filings are little filings made of iron. You're going to sprinkle them on top of the magnet, and then what it will do is it will outline the shape of the magnet even though you can't physically see it underneath there. So what's this got to do with fundamental particles? The idea is that we can't really see quarks, but what we can see is how they interact with other objects. So that's the purpose of this one. So go ahead and try activity number 4 if you've got the equipment for it. Okay, I found out that you can't really make a video longer than 15 minutes on YouTube. It takes too long to download it, so I need to break right now, and I'll be right back and we will finish up this lab.